in this word problem, in 2004, the net value is 43 million. Since it tells us let t equal 0 represent the year 2004, we're going to say that our first point is 0, 43 million. In 2008, that is 4 years later, year 4, the net worth is 62 million. So what I've got here is I'm looking for a function of the worth as a function of time. I'm going to write that down. Worth as a function of time. I'm going to write that as w of t. Instead of f of x, we're going to have w of t. Now, we're going to first need to find the slope of this line. And that means we're going to use the slope formula, which is the difference of the y's, 62 minus 43, divided by the difference of the x's, 4 minus 0. That will be 19 over 4, which is 4.75. We also need a y-intercept, but in this type of problem, when they told us the time equals 0 represents the year 2004, they gave us the y-intercept of 43. So if we were going with y equals mx plus b, we would have y equals 4.75x plus 43. But we're not going with y and x, we've got w as a function of t, so this will be w of t equals 4.75t plus 43 instead. Okay, given this matrix, find the inverse if it exists. Remember how we used the percent sign and we said, switch that diagonal that way and the zeros are going to become minuses instead. We're going to begin by finding the determinant of that matrix. So multiplying diagonals, the first diagonal, negative 3 times 4 is negative 12. The second diagonal multiplying upward would be negative 5, but I'm changing it to positive 5. Adding those together, we get negative 7. The shortcut method for finding the inverse says A inverse will equal 1 over that determinant, negative 7, times, and then on this one diagonal, we're going to change places of the negative 3 and the 4, putting the 4 in the top left corner and the negative 3 down in the bottom right. And on the other diagonal, those little minus signs tell us to multiply by negative 1. So the 5 in the upper right corner becomes negative 5, and the negative 1 in the bottom left corner becomes a positive 1. Now we just multiply that scalar of negative 1/7 into that matrix, and we get negative 4/7, reading across 5/7. Next row will be negative 1/7, and then positive 3/7. And if you want to, you could double check that by multiplying A inverse times A and verifying that you get the identity matrix, or you could have A times A inverse and make sure that you get the identity matrix that way. If your teacher gives you a final exam, which is multiple choice, you might not choose to find the inverse directly. You might just choose to check your choices by using matrix multiplication. Okay, we have an absolute value inequality next, and we want to isolate the absolute value by itself. So we'll begin by adding 3 to both sides and setting this to be greater than or equal to 8. So the absolute value of 2x plus 7 is greater than or equal to 8. Now, this is saying the distance is more than 8 units away from the origin. That tells us the 2x plus 7 is less than or equal to negative 8, or 2x plus 7 is greater than or equal to positive 8. If you watched my other video, you might have remembered the chant, smaller than the small one, bigger than the big one. Now we have 2 separate inequalities to solve. We're going to begin by subtracting 7 on each side, so we'll have 2x less than or equal to negative 15, or 2x greater than or equal to 1. Dividing through by 2 on each side gives us x less than or equal to negative 15 halves, or x greater than or equal to 1 half. In interval notation, this becomes x element of negative infinity up to and including negative 15 halves, united with the interval of values greater than or equal to 1 half. Notice I've got brackets on both ends of these intervals because of the equal signs in the inequalities.